This video is going to talk about what happens when you try to put two alkyl groups on malonic ester in a malonic ester synthesis, and if you try to do it in a not very smart way, what the bad consequences can be. So this is our malonic ester starting material, and we would like to put two alkyl groups on it. Notice the two alkyl groups are different. That usually saves students if they're different from trying to do stupid stuff, but if the two alkyl groups are the same, then people flip out and do not very smart stuff. So when they're different, it's easy. You deprotonate the first time, and then you put the first alkyl group on. So the first alkyl group here is this ethyl bromide, and the second alkyl group is a propyl group. So ethyl is here, and propyl is here. Great. But what if we wanted to make something that had two ethyl groups or two propyl groups? Let's go for two ethyl groups. What would happen here? If we try to do it this way, a lot of times students will go like this and say, oh, I'm just going to do it all at once. Two sodium ethoxides and two ethyl bromides. We add them all together at the same time. So some of the sodium ethoxides, one equivalent, will deprotonate the malonic ester, and that can react with the ethyl bromide. Meanwhile, there is another equivalent of ethoxide and another equivalent of ethyl bromide, and those other two equivalents, we can't make a dianion for diethyl malonate, so what ends up happening is the extra sodium ethoxide and the extra ethyl bromide react to make ether. So you're trying to get two alkyl groups, and you get one of them on there, and the other reagents, the one ethoxide that's extra and the one alkyl halide that's extra react with each other and do a side reaction. You are likely to get this, but you might also get some of these if we have a little bit of elimination. So it's better to always do it stepwise, even if the two substituents are all the same, so that you can avoid this mess.